Hello, good afternoon. I'm Marielle S. I'm a bioethicist and an OBGYN physician. And today I'm going to be talking to you about our work in empowering patients as the owners of their tissue to really unlock its potential for research and empower precision medicine. While I'm a professor at the University of Pittsburgh and Johns Hopkins and a practicing physician at UPMC, I'm presenting to you today from the perspective of a new company that I've formed called Henny. And Henny's mission is really to empower patients as collaborators in research to really unlock that potential of their biosamples and enable a medical future that is person-centered. The image on the left captures what's wrong with how we use patients' tissues today. In that if you or a loved one have surgery and donate your tissue or your tumor for science, you never find out what happens and you don't benefit from that research, even if it's relevant to your health. This is because of a process called de-identification, in which your name and your identifiers are removed from your samples before they go to the biobank or the research lab. A biobank is like a regular bank in that it holds valuable assets to invest in future research. In this case, the investments are into research. Unlike regular banks, biobanks don't issue any credit to the individuals who make deposits. This is a major problem in the era of precision medicine. The reason I went from being a bioethicist to a founder of a company is directly related to the reason why I'm speaking to you today, which is that if a patient donates their sample to science and that scientist discovers a genetic mutation in their research lab, because that person's name has been removed, they have no way to let the patient or their doctor know. And this is not just true for novel mutations that we don't know how to interpret yet. This is true for BRCA. This is true for the mutations that have been most well studied and incorporated into our clinical practice. And still, as many of you may know, these tests are not widely available, even to everybody who has breast cancer. And so the fact that a researcher could take your tissue and learn that there's a BRCA mutation there, which is information relevant not just to you, but your entire family, and not have a way to get that, information back to you or to your doctor, is a major problem for our health institutions. It's not just bad for patients, it's bad for research. A single scientist at one university could be studying the tissues of two sisters, both with the same kind of breast cancer, and not know that those two individuals are related. To me, as a scientist, that's devastating for a condition like cancer, which we know is hereditary and linked not just to genes, but to the location in which you live. As a physician, and as a surgeon, this is also problematic because I'm making decisions with my patients for how we treat them with limited information. And it means that there might be information out there from a part of their body that I removed for their benefit, that we're not able to use that information to inform how we take care of them. There's a lot going on here, so I'd like to step back and talk about what happens if you have surgery and your tissue is removed. The first thing is that it goes to a pathology lab. That's where the doctors in the pathology lab look at it under the microscope to determine what is or what is not in your tissue. After that, by law, a portion of your samples in the form of slides are preserved for a minimum of 10 years. And this is true for everybody who has any procedure in the United States. It's considered part of the medical record. And many of them are kept for far longer than 10 years. 10 years is the minimum. If you donate your samples to science, they might also, those cells, while they're fresh, might be sent to a research lab to be kept alive and studied in the most advanced biomedical research applications. And then the most common thing that can happen if your samples are donated for research is that they're frozen. That's where the biobanking comes in. They preserve it for future use. The truth is that despite all of these important uses of the samples, the vast majority, and in the case that I'm studying here at UPMC at McGee Women's Hospital, 90% of that tissue is thrown away. And that's accounting for all the portions that we preserve for research and future clinical use. As I was saying, these tissues are incredibly valuable for driving the future of precision medicine because it is from the tissue that we get the most unique and specific information from patients and the most rich data. And now we're looking at a particular case at UPMC of breast cancer patients and other patients who've had breast-related disease or breast-related procedures and have donated their samples to our breast cancer biobank. Of those patients, there's 10,000 of them, and each and every one of them has pathology slides. Of the individuals who agreed to donate, about a third of them have frozen samples, and the smallest portion which is just about 200, have those in the laboratory living cells that were created from their own body. Each one of these sample types is incredibly valuable for a number of different biomedical research applications, and in the future, potentially for unlocking solutions directly relevant to those individuals. The problem is, as I mentioned, none of the 10,000 patients in our system are able to ever find out what happens to those samples. And there's a lot of value that could be delivered to those individuals if their names were not removed, if they were not disconnected or disinherited from the value that can come from their samples. On one hand, this could be, a matter of personal meaning. What is your individual contribution to science? And what is it that was learned from your body? As I also suggest, there's a relevance to those, and certainly a growing relevance to the genetic findings and potentially even experimental data that can be very helpful for directing future therapies or making really difficult treatment decisions, especially when you're operating in, a situation like in breast cancer where there's many different treatments and you only have, each chance that you take on a treatment is like cutting a diamond, right? You have one chance and you're making right now we make the best informed decision we can for that patient based on what we know. What if we can combine what we know about the population with what we know from studying that own individual's samples? It's not just about personal meaning and the potential relevance for health, however, because these samples themselves are incredibly valuable, ranging in the hundreds of dollars to thousands of dollars per sample. Those samples are also essential for unlocking critical developments in biomedical science and new intellectual property that can become billion-dollar treatments or diagnostics. This is all from the patient's own samples, from their very flesh and blood. There's a tremendous amount of value, and right now, there's no way for patients to share in any of it. So we talked about the potential personal, health, and even financial value that can come from tissue samples that are donated for research. And truly, these assets are the key to unlocking precision medicine. But we really need patients' help to unlock their value, and I'll explain why. Focused on breast cancer at UPMC, which is the largest academic medical center in the United States, where McGee Women's Research Institute does more NIH-funded women's health research than anywhere else in the country. We have a biobank infrastructure that's really best in class, designed to capture the tissues that are really the most valuable byproduct of healthcare practice. The most scarce, most precious form of patient data are in the cells themselves. And we have a collection that we've created over nearly 2 decades, breast cancer focused, tissue collection. That's where what those 10,000 patients I mentioned had all agreed to participate in. After nearly 2 decades of this breast cancer focused collection, however, less than 10% of those samples have been used for research, which means over 90% are frozen in the biobank today. So never mind the fact that 90% of the tissue itself was thrown away. 90% of the tissue we collected has yet to be used, which means less than 1% has been used for research. And the majority of total of the tissue has been used for research, and the majority of the potential value for research remains unrealized. Why is it that a biobank that knows how valuable these samples are for research is holding on to them rather than ensuring that they're out there doing what they're supposed to be doing and advancing science? You might think it's easy to explain if you consider that each biobank is an institutional silo. It's sitting in between a hospital, a university, a research institution, all of which are funding it to maintain this research resource, the infrastructure that nobody wants to fund. But the problem is that that infrastructure is only for the individuals at that center. So most people in the world who could use those samples, and we had 60,000 collected, most people in the world who could use them simply don't know that they exist. And the people who can log into that system to find out that they exist, don't know enough about the patients to know whether those samples are relevant to their research, because the biobank has the most basic information about, is it tissue, is it tumor, is it normal tissue, is it this kind of cancer or that kind of cancer? Not, did that person take tamoxifen? Not, did that person have family members that had the same cancer? None of that information is in the biobank. And so the researchers who don't have access to that patient information also don't know enough to know whether they'd want to use it. And even if they knew both of those things, they knew that they existed and they knew enough about them, it could be a decade or more that our own local collection would have enough samples of a very particular specific type to do a research project, which requires a number of tissues acting at scale. So biobanks are silos, but that's not that's the beginning of the answer, not the point. The point is that what happens, these biobanks are silos in which they sit between those institutions, and they're not aligned with the interests of the patients who made the donations. They're not accountable to them, right? The patients' names have been removed. And on the other hand, they're not aligned with all the other members of the ecosystem, whether they're researchers, companies, other universities that might want to use those samples because they're guarding them as a local asset. And so this yields a system of misaligned incentives in which those that are managing the samples are not aligned with the patients or the others who might want to put them to use. And the even deeper problem below that, which is the problem that we really hope to solve with your help, is that the ownership of the assets is ambiguous. And so all of the biobanking activity becomes around managing risk of what would happen if the patients found out that we used their sample in this way or that way. Because even though we seek, in many cases, their permission ahead of time, or what we call prospective informed consent, for example, before you go to surgery, no amount of transparency when you're sitting in that clinical situation is transparent enough to really enable all of the potential uses of that sample down the line. And because of that ambiguity and because of the risk and the fact that the patient has been excluded from the picture, and each group feels that they have a right to use the sample, and for these reasons or for those reasons, what ends up happening is nothing. And for the most part, the samples sit there because nobody can decide what we can do with it or who we can tell about these assets. And we're paying to keep them along the way. And to put this in a really personal example, if you have a surgery, for example, with a plastic surgeon, and that plastic surgeon was chosen for their surgical expertise, it's very unlikely that they're collaborating with a breast cancer researcher who might then be sure to use that tissue for learning how to prevent or treat or detect early breast cancer. So extremely relevant to the uses that are very important to the individual patients is that once they're out of the picture, it's really nobody's responsibility to make sure that their samples get used, even if they agree to donate them. We've done over 200 interviews of researchers, physicians, institutional leadership, industry partners, and everyone's question is, who owns the tissue? And everyone thinks that they own the tissue. But by everyone, we mean everyone except the patient, who doesn't know that that sample was collected. They might remember signing a form saying, sure, take my samples for research. They may not remember that. But either way, without that connection, they don't know where their assets are and aren't able to assert themselves as the rightful owners. The core principle underlying our project is the belief that patients are the owners of their tissue. And what we're doing is building technologies to empower patients to take that ownership, to unlock its potential for research relevant to that individual and their families, and to ultimately build that core infrastructure that's missing right now from our health systems that enables findings from research to be combined and then fed back to patients and their physicians to inform personalized care. As a bioethicist, I'm often confronted with the challenge of, pointing out, part of our job is to point out ethical flaws in the existing systems and practices. And it's a difficult position to be in. The reason I'm here talking to you about not just a problem, but about a solution is because we've been studying the technologies that could enable us to change the status quo from something that we think is ethically suboptimal to something that can really realize the full potential of all of the individuals and their combined efforts in the system that we have today. The solution is complicated, but it starts with something that's extremely simple. It's a biobanking app. This enables patients to find their samples wherever they may have had surgery, wherever they may have had procedures done, to track their use, to learn about the research, both the research that might already be ongoing, as well as the research that might happen, and to join studies or even start studies with their own samples. And this last piece is especially critical when we consider the fact that the vast majority of patients whose samples are collected are sitting there. They're waiting to be used. Now we see some screenshots of the demo version of our app, and this shows the core function, which is the bio wallet. And the very first step in unlocking your bio wallet is confirming your informed consent. This is a practice that was already baked into your clinical care if your samples were collected for research. And we start there. And then once we verify your informed consent, we're able to track down your samples. This is showing some examples of different types: tissues, blood, urine, other. I know the screen is far too small to see here, but this is showing an example of what happens once you verify your consent and we're able to start populating the samples that have been collected from you, in this case, in one category here. And then this screen, also too small to see, but just for illustrating purposes, this is what you would see if you were to click on an individual sample to learn more about it. In this case, it's a urine sample, and urine is incredibly valuable for non-invasive biomarker testing and things that are really relevant to our populations. This is an individual sample. It shows you about the basic details of the sample, where it exists, how much of it there is, and whether or not it's in use. In this case, this sample's been sent to a research lab. Well, of course, that raises the next question of, what's happening with my sample today? So this is a new paradigm for research participation, and I want to walk you through how it works in our very first iteration, our very first pilot. What happens, and we're focused here in Pittsburgh at the UPMC Hillman Cancer Center, and for all patients who have had procedures there, we are enabling them starting now today to provide us with their name and date of birth. We search for whether they've already consented to be part of the biobank, the breast cancer biobank. If we find their breast cancer biobank consent form, which has been scanned, should have been scanned, if it exists, it was scanned into our electronic medical record systems. This is showing you just a snippet of what that form, the top and the bottom of that form look like in the generic non-filled out version. We find your form with your signature, date, time, all those things, and we send it to you for confirmation. What happens next is you validate that that was, in fact, yes, that's my signature. Yes, I signed that. I was consented by, so-and-so. You recognize your name, that the person, and the name of the person who had gone through the consent form with you. And then we take your consent form and we have the opportunity to take your form and the unique details, and you could see how this is a little bit off angle, and that's because this is a scan. This is coming from something that looked like a perfect PDF here on the prior page. That same form, once it's been signed by a person and scanned in, looks a little irregular. That irregularity is good. It means it's totally unique, and it is unique to that person. We take their form and we make a personalized token. And that token, we're giving you an example here for the McGee Women's Research Institute biobank. We show you takes pieces of that consent form and a small snippet of the patient's signature, not enough to reveal their identity, enough for them to recognize that it's valid and that it's legitimately theirs. And we mint that as an NFT. And this NFT, which is short for a non-fungible token, becomes a privacy-preserving donor badge. And the function of this token is to really recognize your contribution to the biobank donor community. So the very first thing that this token enables you to do, the way you could think about it, it's like the digital version of the t-shirt you get for donating blood, right? If you give blood, you get cookies, you get a t-shirt, you might get some other articles of appreciation, other tokens of appreciation. If you donate your tissue to science today, you get nothing. You don't find out what happens, and you get no recognition. So we're starting off by creating a digital version of a donor badge. And this donor badge signals your membership in the community and your investment in a shared mission of advancing breast cancer and related research. Critically, it also is your key to getting access to updates about your samples. So that was the key, that consent form, that section on the application where you fill out we validate your consent form, and then it unlocks the details of your samples. This is the key that enables you to do that, because it shows that your informed consent is not something one time accepting the cookies, that you signed a form and forgot about it. It's something that's an ongoing relationship, an ongoing membership, just like your samples are still there. And if your samples are being used for research, they're still in use. And they might have findings that over time are going to become relevant to you. This token also grants you rights to the community. It's about identifying yourself as a member of a community who have rights to make decisions about what kinds of projects are the best use of your samples. Should it go to a company? Should it go to academic researchers only at universities? Should it stay at your university health system, or should it go to another university where there's a researcher who might want to use it tomorrow instead of waiting until somebody comes along in your local center? And most critically, it connects you to your samples for life. And this is not just for you, it's also for anybody else who might come after you. And so this token and the rights attached to it are something that you can, as a digital asset, that you can pass on to your family members, biological and non-biological, so that they can maintain that connection and share in the benefits of the research that might be done on your samples. Our system is empowered by non-fungible token technology, which is a part of the blockchain technology ecosystem. And I don't want to get overly technical here, but I want to explain why what you might have heard of as a, $100,000 picture of a cartoon of an ape, or a picture of a cat that looked like a Pop-Tart, why is that relevant to this incredibly sensitive context of our personal tissues and what's done with them, and whether or not we have a right to access the benefits of research from our own samples? And the reason is that NFTs as a technology are really enabling us to apply to a digital object, like a picture, all of the features that you and your samples already have. Each sample is inherently scarce and inherently unique, just like the person it came from. There's a limited supply of them, just like your tissue is in limited supply. It's equal for all people. The fact that human tissue is this asset that we all have the same amount of, more or less. Each piece of tissue is forever connected to that individual. So this idea of immutable provenance is about maintaining that connection, because all future uses of your sample are relevant to you or to your family. And all individuals who ever use your sample need to know about you and your family to really learn from them. And the core tenet of decentralized ownership, which really NFTs and Web3 technology are about, is all about the user-owned world. Well, if you don't own a part of your body simply because it's removed from you, how can you ever own the data about your body? And we really start from a first principles approach, where decentralized ownership of the human body is the one universally agreed upon core tenet of democracy. That I own my body, you own yours, it's for life. I can work for you or you can work for me, but we can't own each other. And similarly, we believe we can't own each other's tissues. And so NFTs are a technology that enables us to better represent what those samples really are in a digital way, and to allow us to share those samples while at the same time leveraging the blockchain features of privacy and encryption, the ability to trust each other, even if we don't know each other or trust each other, because we can all trust in a common computer algorithm that's proving transparently, what's happened in our supply chain of human tissue, and that is automating the processes of ensuring that that patient is getting the follow-up, and that doctor is able to pull on all of the different sources of learning from that one individual into that one individual's care. We don't get there if we can't first track and really map out where all of your samples have gone. I think of it as like a diaspora in the current situation, and our job, which we're assisting ourselves with NFTs, is to pull all of that back to the individual. I want to take a moment to really acknowledge the incredible team that I have working with me to help make this technological solution to a major ethical problem a possibility. And that includes Adrian Lee, who's the head of precision medicine and a renowned breast cancer researcher. Jeff Kahn at UPMC and University of Pittsburgh. Jeff Kahn is the director of bioethics at Johns Hopkins, and Robert Miller is an oncologist, clinical trialist, and patient data technologist from the Mayo Clinic. I have a fantastic team of developers who've taken up, coming from a technical perspective, have taken up the cause of patients and their tissue as their own, and that are helping us build technologies to enable patients to assert their ownership of their samples, to enable their value, to enable them to receive the existing value that exists, and to propel that system forward so that those samples that are sitting, frozen in limbo can be put to their intended use. And I have a fantastic team of patient advocates and researchers that are engaging with our technology and helping to inform how we're developing it to serve the needs of our communities. And we're fortunate to have our work grant funded by the Emerson Collective, which is the Jobs Family Social Impact Investment Fund, the Beckwiths, the Board of Directors of UPMC, and McGee Women's Research Institute, as well as the Institute for Precision Medicine, and really a growing group of patient advocates, including FORCE, 412 Thrive, GRASP, and the Black Women Blockchain Council, who are really helping us make sure that these technologies are serving their intended purpose for their intended communities. What this diagram shows is at a very high level how we envision the future. with the biobank as a shared resource for patients who remain the owners of their samples for life, with the researchers that they're collaborating with, and the physicians that are helping to obtain the tissues and then to put the information created by the researchers with the assistance of the patients back into the clinical care. It's a futuristic vision that starts, that has a lot of steps along the way, but it starts with something very simple that we're excited to be debuting today, which is that patient-facing biobanking app. The purpose of our decentralized biobanking model is to enable the patient to remain the owner of their samples, just like they're the owner of the rest of their body for life. And at the same time, to enable them to share those samples as widely as possible without revealing their identity to the others who might be doing research or have additional value to add, and while retaining the ability to benefit from what is learned from all of the different research uses of their samples. In my mind today, your biosamples are spread across like a diaspora. And the goal of our solution is to bring each and every one of them to live to their best potential value for you and your family, and then to bring that value home to where it came from. We're excited to be releasing today the first version of our application, the patient-facing biobanking app, that will enable you to learn about what was collected and track your samples, and the first step towards participating as a genuine stakeholder in research on your own tissues. We're releasing our app today in the App Store and Android, for both iOS and Android. And we're starting here in Pittsburgh with the UPMC breast cancer donor community. To learn more about what we're doing, join our community, and potentially sign up for our pilot, you could check out our website, henny.co. And I appreciate your time listening today. I'm excited because this is a revolution in which we can re-envision patients as genuine owners of their samples and enable patients to really drive precision medicine forwards. I am deeply appreciative of FORCE and the opportunity to collaborate with this community. And I'm looking forward to taking your questions and to continuing the conversation. Thank you again, and we hope that you'll join us.